Welcome to Pre-Calculus. Today we will investigate simplifying complex fractions. We'll take a look at two examples. Our first example is the complex fraction m squared over 2m minus 3 all over m squared over 5. And whenever we're dealing with a complex fraction simplifying, I really want to reduce this fraction over a fraction down to one single numerator over denominator. So what I notice here with this example is that it really is just a fraction over a fraction. And when I've got that arrangement, really I can immediately cancel it by applying keep change flip. Now, keep change flip we use as an acronym to just remind ourselves how that works. Let's go through all the steps here just to justify keep change flip. So I would really start in the denominator, and what I would multiply the denominator by is the reciprocal of that lower fraction. So I'm going to multiply it times 5 over m squared. Now if I do that in the denominator, I have to repeat that product above. So I'm going to also multiply by 5 over m squared. And what that will do for my denominator is cancel it entirely. I've got m squared divided by m squared, so that's a 1. I've also got 5 divided by 5, that's also 1. And so what it leaves me with is keep the first fraction, change division to multiplication, and then change the lower fraction to its reciprocal, keep change flip. Once I've got that arrangement, I just need to multiply across. So this is now m squared times 5, which is 5m squared, all over 2m minus 3, also times m squared. Now I want to simplify that down as much as possible. I'm somewhat tempted to distribute the m squared through that binomial, but I see that really I've got a cancellation. So instead of distributing, I want to cancel m squared, and that really reduces my fraction down to just 5 over 2m minus 3. And that is complete. So we've reduced that fraction. We've simplified the expression down to one single numerator over denominator. Let's take a look at our second example. So the difference between our first and second examples is now instead of just a fraction over a fraction, I have a difference of fractions in my numerator. So x minus 3 over 4 minus x minus 3 over x minus 5, all over simply x minus 5. So in a way, the denominator of this is simpler, but the numerator is more complicated. So to do this, what I want to do is I want to start by combining my fractions in the numerator. So I'm going to rewrite, and I'm going to create a least common denominator. So for x minus 3 over 4, I want to multiply that times x minus 5 above and below so that I've got that common denominator 4 times x minus 5. Similarly, for the second fraction, x minus 3 over x minus 5, there I want to multiply by the 4 above and below. And so my first step is really combine those numerator fractions. I'll leave the x minus 5 in the denominator unchanged. So on my next step, I'm going to show that combination in my numerator. So I'm going to write x minus 3 times x minus 5 minus x minus 3 times 4 all over the common denominator 4 times x minus 5, again over x minus 5. Now what I can do is simplify and combine like terms in my numerator. So in my numerator of the numerator, I'm going to have x minus 3 times x minus 5. So that's going to be the quadratic x squared minus 8x plus 15 all minus 4x minus 3. So I'll go ahead and write that with parentheses first. In fact, I did that distribution incorrectly. 4x minus 12. But then I want to get rid of the parentheses, so I'm going to distribute that negative there. So it's going to be minus 4x and then plus 12. And that's going to be all over 4 times x minus 5 over x minus 5. So in my numerator now, I've got like terms, so negative 8x and negative 4x. I've also got 15 and 12. So I'm going to combine those together. That'll give me my new numerator of the numerator, x squared minus 12x plus 27 over 4 times x minus 5 over x minus 5. So now what I'm really ready to do is combine that denominator with my upper fraction. So I use the same strategy we used in our first example. I'm going to multiply by its reciprocal, 1 over x minus 5. So in the denominator, that'll cancel. I'll also multiply by 1 over x minus 5 here in the numerator. So what we get next, we'll go ahead and do the denominator first. It's going to be 4 times x minus 5 times x minus 5. And then I see I could probably factor that numerator in its current form. So I'm looking for numbers that multiply to 27, add to negative 12. That's x minus 9 times x minus 3. And that really is a final answer. I could be a little more efficient in my denominator. I would say my final form here is x minus 9 times x minus 3 over 4 times x minus 5, since there's two of those factors squared. And that's complete. Again, I've taken multiple fractions in the numerator over denominator to a single numerator over denominator. Thanks for joining for this investigation of simplifying complex fractions. See you soon.